Now in this lecture we'll answer on two questions. On both questions we'll find out the area of a trapezoid. So what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. So trapezoid ABCD is a quadrilateral because it has four sides, and because of the fact that in quadrilateral ABCD side AB is parallel to the opposite side DC, this quadrilateral is a trapezoid. The two parallel sides, that is to say AB and DC, are defined as the bases of this trapezoid, and the area of trapezoid ABCD equals to the sum of its two parallel bases times the height over 2. If we define the base of trapezoid ABCD, this AB as B and DC as A, then the sum of its two parallel bases is A plus B times the height H over 2. So the area of trapezoid ABCD equals to the sum of its two parallel bases, that is A plus B, times the height H over 2. The height H must create 90 degrees with the two parallel bases. You can see here that the height H creates 90 degrees with the base AB, and the height H also creates 90 degrees with the base DC. So, again, a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid equals to the sum of its two parallel bases times the height over 2. The height must create 90 degrees with the two parallel bases. Okay, so here in the first question, our mission is to find out the area of this trapezoid ABCD. We know that the perimeter of this trapezoid ABCD is equal to 16 units. What is a perimeter? A perimeter is the sum of the lengths of all the sides of this trapezoid ABCD. That is to say, it is equal to AB plus AD plus DC plus CB. And that sum is equal to 16 units. In addition, we know that those two angles are right angles. Side AB equals to 2 units in its length. We also know that side BC equals to side DC. Again, our mission is to find out the area of this trapezoid ABCD. We know that the perimeter of this trapezoid ABCD is equal to 16. That is to say, AB plus AD plus DC plus CB. In total, the sum of those four sides of trapezoid ABCD is equal to 16 units, according to what is given as the question. AB equals to 2, so we substitute AB by 2 plus AD. We define the length of side AD as A, and we define the length of side DC as B. And because of the fact that BC equals to CD and CD is B, therefore BC must be also equal to B units in its length. So AB is 2, AD is A, plus DC is B, and CB is also B. In total is equal to 16. That is the perimeter of trapezoid ABCD. Here we subtract 2 from this equation, and we get that A plus B is A plus 2B is equal to 16 minus 2 is 14. Here we subtract 2B from this equation, and we get that A equals to 14 minus 2B. Equals to 14 minus 2B. AD equals to A units in its length, and A equals to 14 minus 2B. In the next step, we will do a construction. That is to say, from the vertex B, this vertex B of this trapezoid ABCD, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we're going to do quadrilateral AB, MD. Inside this quadrilateral AB, MD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4-piece angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this 4-piece angle must be equal to 90 degrees in its size. So inside this quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a right angle if not a square. So we relate to this quadrilateral ABMD is a right angle because it has 4 right angles. But we also know that the opposite sides of a left angle are equal to each other. So in left angle ABMD, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same left angle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B in its length. What is the length of this missing line segment? Line segment MC. From the drawing, it is very easy to see that MC equals to DC minus DM. Again, MC equals to DC minus DM. So I'll write it down. MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition, minus DM. We just right now found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units. In the next step, I'll copy this right triangle BMC in the new page, and we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared. Plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total we should find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. So here we open the brackets on this side of this equation and we get that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that's actually 2B squared is 4B squared, minus 2 times 14 is minus 28, and minus 28 times 2B is minus 56B. Plus B minus 2 squared. B minus 2 squared equals to B squared plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. In this side of the equation, after I cancel B squared, we left with nothing, that is to say 0, while on the other side of this equation, this side we have 196 plus 4 is 200. We also have minus 56B, minus 4B is minus 60B, and we have plus 4B squared. So total we found out that 0 equals to 200 minus 60B plus 4B squared. Here we divide this equation by 4, and we get that 4B squared over 4 is B squared, and minus 60B over 4 is minus 15B, and 200 over 4 is 50, and it is equals to 0 over 4 is 0. So in total we have found out that B squared minus 15B plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b. So x equals to b. Capital B is the coefficient of this quadratic equation, while small b is the variable that we are looking for in this quadratic equation. So x, the variable that we are looking for is b, so x equals to b. The coefficient a, this is capital A, is equals to 1. The coefficient b, that is capital B, is equals to minus 15. And finally, the coefficient c equals to 50. The only thing that is left to do is to put this data in our general quadratic equation in order to find out the value of the values of b, because x equals to b. So we'll do it now. X equals to b, so we will substitute x by b, and we get that b equals to minus capital B. That is the coefficients of our specific quadratic equation, and we know that the coefficient b equals to minus 15. If b equals to minus 15, minus b will be equal to minus 15, that is plus 15. plus minus the square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225 minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50, minus 4 times 50 is minus 200. Divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in total, we should find out that b equals to 15 plus minus square root of 225 minus 200. 225 minus 200 is 25, and the square root of 25 is 5. So in total, we should find out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. The first solution, we define the first solution for b as b1, and the second solution for b is b2. So the first solution for b is b1, and b1 will be equal to 15 plus 5 over 2. Fifteen plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1, that is 10. And the second solution for b is b2, and b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is equals to 5 units in its length. So we have two solutions for b. The first solution for b is b1, that is 10, and the second solution for b is b2, that is 5. This is side AD of trapezoid ABCD, and A is the length of side AD. So A is the length, it must be a positive number. So side AD equals to A units in its length, and A itself equals to 14 minus 2B. So 14 minus 2B is the expression for the length of side AD. But the length of side AB must be a positive number. What is a positive number? A positive number is a number that is greater than 0. So we can write here that it must be greater than 0. And from this equation, or from this inequality, we derive that 14 minus 2b is greater than 0. Again, 14 minus 2b is greater than 0. Okay? 14 minus 2b must be greater than 0. Here we need 2b to this inequality, and we get that 14 is greater than 2b. Here we will divide this inequality by 2, and we get that 14 over 2 is 7, is greater than 2b over 2 is b. In total, we have found out that b is less than 7 units from one side, but from the other side, according to the first solution for b, b1 equals to 10. That is greater than 7, but b must be less than 7. So this solution is an incorrect solution. We cancel the solution, and you're left only with the second solution that is possible for b, that is b2, that is equals to 5. b2 equals to 5. You can write down that b equals to 5 because we have only one solution for b. b equals to 5. That is to say, DC, that is equals to b according to our definition, is equal to 5 units in its length. B equals to 5, AB equals to 2, and A, side AD is equals to A is equals to 14 minus 2B. B is 5, so minus 2B is minus 2 times 5, that is minus 10, and 14 minus 10 is 4. So in total, we should find out that AD is equals to A is equal to 4 units in its length. Our mission is to find out the area of this trapezoid ABCD. So, what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases times the height over 2. The two parallel bases are AB and DC, and the sum of those two parallel bases is AB plus DC. Times the height. The height must create 90 degrees with two bases AB and DC. And AD indeed creates 90 degrees with the base AB, and AD also creates 90 degrees with the base DC. Therefore, AD is the height of trapezoid ABCD. So it is times the height AD divided by 2. AB is 2 according to what is given as the question, plus DC. DC is 5 because it is equals to B and B equals to 5. So DC is 5 plus 5 times AD. We've already found out that AD equals to 4 units in its length divided by 2. 2 plus 5 is 7 and 4 over 2 is 2. So in total this expression equals to 7 times 2, that is 14 square units. So if you found out that the area of trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units in its size. And again, if you found out that the area of this trapezoid ABCD, that is the area that we're looking for in this question, is equal to 14 square units. So we finish with the first question. In the next step, I will present to you the second question, and we will solve the second question of this lecture. Actually, in the second question, we have to find out the area of another trapezoid with the same name. The name of the trapezoid is also ABCD, but it is a different trapezoid. So our mission in this second question is to find out the area of this trapezoid ABCD. It is different trapezoid. So in the drawing we have line segment AD that is equals to 2x units in its length. BC equals to x units in its length. Line segment AM equals to 3 units. Line segment BC equals to 2 units. Those two angles, they are both right angles. This is angle A and B, that is also a right angle. Again, our mission is to find out the area of this new trapezoid, ABCD. Okay? So first of all, we define the size of this angle, angle BMC as alpha. And in the right front angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M here, the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? Here we have this angle that is alpha plus this angle that is 90 degrees plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles of the upper side of the third line DC at point M, exactly like rule 3. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We focus on those two right angles, the right big triangle ADM and the right triangle BCM. Those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both right angles, they are equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you found out that all the figures of this big right triangle ADM are correspondingly equal to all the figures of this small right triangle BCM, and therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. If you found out that this is the right big triangle ADM, is similar. This is the sign of similar to this right small triangle BCM according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of the big right triangle ADM over side MC of the right small triangle BCM is equal to side DM of the right big triangle ADM over side BC of the right small triangle BCM. And again, we know that side AD of the big right triangle ADM over side MC of the small right triangle BCM equals to side DM of the big right triangle ADM over side BC of the small right triangle BCM. And it is also equals to side AM of the right big triangle ADM over side BM of the right small triangle BCM. So in total, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equals to DM. DM is also the missing side, so we leave it as it is. Over BC. BC is x. And it is equals to AM. AM is 3 units according to what is given as the question. Over BM. BM is 2 also according to what is given as the question. So in total, we actually found out that two x over MC equals to DM over x equals to 3/2. So those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. According to equation 1, we get that 2x over MC equals to 3/2. So I write it down. So according to equation 1, we should find out that 2x over MC equals to 3/2. Here we multiply this equation 1 by MC, and we get that according to equation 1, 2x equals to 3/2 times MC. So here we multiply this equation 1 by 2 and then we divide it by 3 simultaneously, and we get that MC equals to 2 times 2x over 3. So MC equals to 2 times 2x is 4x over 3. So in total, we found out that MC equals to 4x over 3 units in its length. So I write it down. This is side MC that equals to 4x over 3 units in its length. Those two expressions are also equal to each other, so we'll get equation 2 from those two expressions that are equal to each other. So according to equation 2, actually, we get that dm over x equals to 3/2. And again, according to equation 2, we get that dm over x equals to 3/2. Here we multiply this equation 2 by x, and we get that according to equation 2, dm equals to 3x over 2 units in its length. If we found out that the length of this side dm is equals to 3x over 2 units in its length. In the next step, I'll copy this right small triangle BMC in a new page, and we'll implement the Pythagoras theorem on this right small triangle BMC. Here by PT is the version for Pythagoras theorem. The hypotenuse BM equals to 2 units in its length, according to what is given as the question. BC, side BC also equals, BC equals to x, also according to what is given as the question. And we just right now found out that side MC of the right triangle BMC is equals to 4x over 3 units in its length. So here, this is the right small triangle BMC that I call it from the original drawing. In this right small triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. So I write it down. BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it is equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, we should find out that four equals to x squared plus 16x squared over 9. So here we multiply x squared by 9, and then we divide it by 9 in order to overcome a factor with this expression, and we get that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared over 16x squared is 25x squared over 9. So in total we found out that 4 equals to 25x squared over 9. Here we multiply this equation by 9, and we get that in total 25x squared equals to 9 times 4, that is 36. So here we divide this equation by 25, and we get that x squared equals to 36 over 25. So here we take a root out of this equation, and we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total x equals to 6/5 units in its length. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? Actually, according to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. The two parallel bases in this trapezoid ABCD are AD and BC. So it is AD plus BC times the height. The height of this trapezoid ABCD is DC. Why this is the height? Because of the fact that DC creates 90 degrees with the base AD, and DC also creates 90 degrees with the base BC. Therefore, the height of trapezoid ABCD is DC divided by 2. So in total, if we found out the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC times the height DC over 2. AD is 2x plus BC. BC is x times the height DC. The height DC in total equals to 3x over 2 plus 4x over 3. So I write it down. The height DC equals to 3x over 2 plus 4x over 3. All divided by 2. X plus x is 3x, and here we have inside the brackets 3x over 2 plus 4x over 3. So here we take 6 as a common factor out of those two expressions by multiplying this expression 3x over 2, both the numerator and the denominator of this expression by 3. And we get that 3x times 3 is 9x over 2 times 3, that is 6. Likewise, we multiply this expression, both the numerator and the denominator of this expression by 2, and get that 4x times 2 is 8x, so it is plus 8x, and 3 times 2 is 6. All divided by 2. So in total, we found out that the area of trapezoid ABCD is equal to 3x times 9x plus 8x over 2 times 6. So it is 3x, and 9x plus 8x is 17x, so this times 17x, divided by 2 times 6. Here we we divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x, so in total in the numerator we left only with x times 17x. And in the denominator we have 6 over 3 is 2, so in total in the denominator we left only with 2 times 2. So in total we have x 17 times x over 2 times 2, that is 4. So the area of trapezoid ABC equals to 17 over 4 times x. But we have already found out that x equals to 6/5, so we substitute x by 6/5, and we get that the area of trapezoid ABCD in total it is equal to 17 over 4 times x. So x is 6/5, we substitute x by 6/5, and we have x again, so it is again 6/5. So in total we actually found out that the area of trapezoid ABCD is equal to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we cancel these three numbers and substitute these three numbers by 9, because 36 over 4 is 9. So in total in the numerator we left only with 17 times 9 over 5 times 5, that is 25. So in total the area of trapezoid ABCD equals to 17 times 9 over 25. 17 times 9 is 153 over 25. 123 over 25 is equal to 6.12 square units. So in total we should find out that the area of trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers it is equal to 6.12 square units. And that is the answer to the question. I repeat again, we should find out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. In the next step, in the lecture, we'll start with the first question, of course. First of all, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. ABCD is a quadrilateral because it has 4 sides, and because of the fact that side AB is parallel to the opposite side DC, this quadrilateral is defined as a trapezoid. The two parallel sides, that is to say AB and DC, are defined as the bases of the trapezoid. So if we define the left of side AB is B and the left of side DC is A, then the area of this trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually A plus B times the height h over 2. Repeat again, the area of trapezoid ABCD equals to the sum of its two parallel bases, that is actually A plus B times the height h over 2. The height h must create 90 degrees with the two parallel bases. Okay? So, in the first question, our mission is to find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid ABCD is equal to 16. So what is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum of the lengths of all the sides of this trapezoid ABCD. Again, the perimeter of trapezoid ABCD is the sum of the lengths of all the sides of this trapezoid ABCD. That is to say, it is AB plus AD plus DC plus CB. And the sum of the lengths of all the sides of this trapezoid ABCD is 16 units according to what is given as the equation, that is the perimeter of this trapezoid ABCD. In addition, we know that side AB equals to 2 units in its length, and side BC equals to side DC. Those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we know that the perimeter of this trapezoid is 16, that is to say AB plus AD plus DC plus CB equals to 16. I repeat again. The perimeter of trapezoid ABCD equals to the sum of the lengths of all the sides of trapezoid ABCD. That is to say it is AB plus AD plus DC plus CB, that is equals to 16. AB is 2, therefore we substitute AB by 2. We define side AD as H, that is to say AD equals to A units length. We define the length of side DC as B, and because of the fact that BC equals to CD, side BC must be also equal to B units in its length. So in total, the area of this trapezoid ABCD must be equal to AB, that is 2, plus AD, that is A, plus DC, that is B, plus BC, that is also B. So repeat again, the area of the perimeter of trapezoid ABCD will be equal to 2 plus A plus B plus B. That is actually 16 units. That is the perimeter of trapezoid ABCD. Here we subtract 2 from this equation. We finally found out that 16 minus 2 is 14. And we have A plus B plus B, that is A plus 2B equals to 14. Here we subtract 2B from this equation. We finally found out that A equals to 14 minus 2B. So the length of side AD, that is A, is equals to 14 minus 2B units in its length. In the next step, we did a construction, that is to say, from this vertex B of this trapezoid ABCD, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we create a quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 450 angle, in total it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 450 angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be its right angle plus a square. So related to this quadrilateral ABMD is right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle ABMD, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the symbol, in the same rectangle ABMD, side AD must be equal to the opposite side BM, but AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B in its length. What is the length of this missing line segment MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B according to our definition, minus DM. DM is equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2. In the next step, we'll complete this right triangle BMC in a new page and we implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is the right triangle BMC that is according to the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equals to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared, plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets on this side of this equation, and we found out actually that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14, that is minus 28, and minus 28 times 2B is minus 56B. And we have also plus b minus 2 squared. B minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b minus 2 times b times 2, that is minus 4b. Here we have b squared on both sides of this equation, so b squared will get cancelled. After we cancel b squared, in this side of the equation we have nothing, that is to say 0. While on the other side of the equation we have 196 plus 4, that is 200. And we also have minus 56b minus 4b is minus 60b plus 4b squared. So in total, if you found out the 0 equals to 200 minus 60b plus 4b squared. So here we divided this equation by 4 and found out the 3 that 4b squared over 4 is b squared, minus 60b over 4 is minus 15b, and 200 over 4 is 50. So in total, if you found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus 4 to b squared minus 4 times a c times minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b, so x equals to b. Actually, this is a small b, while capital B is the coefficient of this general quadratic equation. So small b is the variable that we are looking for, while capital B is the coefficient of this general quadratic equation. So in our specific quadratic equation, so only mentioned before, the variable that we are looking for is b, so x equals to b. The coefficient a equals to 1, the coefficient b equals to minus 15, this is actually capital B equals to minus 15, and the coefficient c equals to 50. So the only thing that is have to do is to put this data inside this general formula for x, and this way we find out the value of the values of b, because the variable that we are looking for in our specific quadratic equation is b. So we actually substitute x by b because x equals to b, and we found out the 3 that b equals to minus capital B. Minus capital B is minus 15. Capital B is minus 15, therefore minus b is minus 15, that is plus 15, plus minus b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a, that is 1. So minus 4 times 1 is minus 4 times c, that is 50. So minus 4 times 50 is minus 200. Divided by 2a. A is 1, so 2 times a, that is 2 times 1, that is 2. So in total, if we found out that b equals to 15 plus minus, inside the root we have 225, that is 225 plus 200, that is 25, and the square root of 25 is 5. So in total, if we found out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We define the first solution for b as b1 and the second solution for b as b2. The first solution for b is b1, and b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, b1 equals to 10, and the second solution for b is b2, this equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, this equals to 5, and the first solution for b is b1, this equals to 10. We know that AD is one side of trapezoid ABCD, and the length of side AD is A. And A equals to 14 minus 2B. And again, AD equals to A units in its length according to our definition, and A itself equals to 14 minus 2B. So 14 minus 2B is the expression for the length, and therefore it must be a positive number. What is a positive number? It means that it must be greater than 0. So from this long equation, we derive that 14 minus 2b is greater than 0. So here we added 2b to this inequality. When we found out that 14 is greater than 2b, we divided this inequality by 2. When we found out that 14 over 2 is 7, and it is greater than 2b over 2 is b. So b must be less than 7 units from one side, but from the other side, according to the first solution for b is equals to 10, that is greater than 7. But b must be less than 7. Therefore, this solution is incorrect solution, so we cancel this solution, and we're left only with the second solution that is possible for b, that is b equals to 5. So if b equals to 5, it means that this side DC that equals to b is 5, AB is 2, and AD equals to 14 minus 2, BB is 5, so minus 2b is minus 2 times 5, that is minus 10. And 14 minus 10 is 4. So in total, AD is equals to A is equals to 4 units. Again, our mission is to find out the area of this trapezoid ABCD. What is the area of trapezoid ABCD? Is equals to the sum of its two parallel bases, that are actually AB plus DC, times the height, that is AD over 2. And again, the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC, times the height, that is AD over 2. AB is 2 plus DC. DC is B and B is 5. And again, AD is 2 and DC is 5. And we have times AD. AD is 4. AD is 4 divided by 2. So 2 plus 5 is 7. And 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So we shall find out that the area of this trapezoid ABCD is equal to 14 square units. So we finish with the first question. In the next step, I present the second question, and we solve the second question of this lecture. Our mission in the second question is to find out the area of another trapezoid with the same name, trapezoid ABCD. So actually, this is trapezoid ABCD. That is another trapezoid. It is not the same trapezoid as in the first question. So we know that AD equals to 2x units in its length, BC equals to x units in its length. Those two angles are right angles, and this is angle A and B, that is also a right angle. We also know that line segment AM equals to 3 units in its length, line segment BM equals to 2 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle BMC as alpha. So in the right front triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first BC angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, and it is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M here, so here the sum of the angles must be equal to 180 degrees, according to rule 3, that states that the sum of the angles on one side of a straight line is equal to 180 degrees. In our specific case, the sum of the angles on the upper side of DC at point M must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, plus this angle that is 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles of the upper side of DC at point M according to rule 3. Therefore, this first angle must be equal to 90 degrees minus alpha. So, in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we focus on the big right triangle ADM, and and in the small right triangle BMC. Those two angles are both equal to alpha, therefore they are equal to each other. Likewise, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees also alpha, therefore they are equal to each other. So we found out that all the figures in the right triangle ADM, in the right big triangle ADM, are correspondingly equal to all the figures of this right small triangle BMC. Therefore, those two right triangles are similar to each other according to angle similarity rule. So if we found out that the right big triangle ADM is similar to, this is the sign of similar to the right small triangle BCM according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of this right big triangle ADM or side MC of this right small triangle BCM is equal to side DM of this right triangle ADM over side BC of this right small triangle BCM, and it is also equal to side AM of the right big triangle ADM over side BM of this right small triangle BCM. Repeat again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is equal to DM. DM is also the missing side, so we leave it as it is. Over BC. BC is x. And it is equal to AM. AM is 3 over BM. BM is 2. So in total, we found out that 2x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, therefore we can get equation 1 from those two expressions that are equal to each other. That is to say, 2x over MC equals to 3 halves. Again, according to equation 1, 2x over MC equals to 3 halves. Here we multiply this equation by MC, and we shall find out that 2x equals to 3 halves times MC. Here we multiply this equation by 2 and then we divide it by 3 simultaneously, and finally found out that MC equals to 2 times 2x over 3. 2 times 2x is 4x, so in total this expression equals to 4x over 3. So we found out that MC equals to 4x over 3 units instead. So this is side MC that is equals to 4x over 3 units instead. Those two expressions are also equal to each other, therefore we get the equation 2 from those two expressions that are equal to each other. So according to equation 2, we get that dm over x equals to 3 halves. According to equation 2, dm over x equals to 3 halves. Here we multiply this equation 2 by x, and finally found out that dm equals to 3x over 2. So dm equals to 3x over 2. In the next step, I copied this right small triangle BCM in a new page, and we implemented the Pythagoras theorem on this right small triangle BCM. This is the right small triangle BCM that according to the origin of knowing. According to the Pythagoras theorem, in this small right triangle BCM, BM squared, that is the square of the opposite, equals to BC squared plus CM squared. BM is 2, therefore BM squared is 2 squared, that is 4, and is equals to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared is 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, we shall find out that 4 equals to x squared plus 16x squared over 9. Here we multiply the x squared by 9 and then we divide it by 9 in order to overcome factor with this expression. And we found out that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared. So we have 25x squared over 9 equals to 4. 25x squared over 9 equals to 4. Here we multiply this equation by 9 and finally found out that 25x squared equals to 9 times 4, that is 36. Here we divided this equation by 25 and found out, okay, that x squared equals to 36 over 25. Here we took a root out of this equation and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6 fifths. X equals to 6 fifths. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. The sum of those two parallel bases of trapezoid ABCD is AD plus BC times the height, that is DC over 2. So the area of trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC times the height DC over 2. AD is 2x and BC is x. Again, AD is 2x and BC is x times DC. DC in total equals to 3x over 2 plus 4x over 3. And again, DC in total equals to 3x over 2 plus 4x over 3. So there, trapezoid ABCD equals to 2x plus x, that is 3x. So here we have 3x over 2 plus 4x over 3. So we took out 6 as a common factor from those two expressions by multiplying this expression both the numerator and the denominator of this expression by 3. So 3 times 3x is 9x and 2 times 3 is 6. So total, this expression equals to 9x over 6. Likewise, we multiplied both the numerator and the denominator of this expression by 2 and finally found out that 2 times 4x is 8x and 2 times 3 is 6. So in total, we found out that the area of trapezoid ABCD equals to 3x times 9x plus 8x over 6 times 2. So it is 3x and 9x plus 8x is 17x over 2 times 6. Here we divided both the numerator and the denominator of this expression by 3 and finally found out that 3x over 3 is x. So in total, in the numerator we left only x times 17x, and we also divided 6 by 3. 6 over 3 is 2, so in total we left here with 2 times 2. So in total, the area of trapezoid ABCD equals to x times 17x over 2 times 2. 2 times 2 is 4. So in total, the area of trapezoid ABCD is equal to 17 over 4 times x times x. But we have already found out that x equals to 6 fifths. Therefore, we substitute x here by 6 fifths. So we have 2 times x, so we substitute x by 6 fifths, and we have also another x that is 6 fifths. So the area of trapezoid ABCD in total is equals to 17 over 4 times x, that is 6 fifths, times x again, that is 6 fifths. 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9. So in total we left only 17 times 9 in the numerator, and the denominator we have 5 times 5, that is 25. 4 were cancelled. So in total actually 4 was cancelled. In total, we found out that the area of trapezoid ABCD equals to 17 times 9 over 25. 17 times 9 is 153 over 25. 153 over 25 is 6.12. So in total, we found out the area of this trapezoid ABCD, that is the area that we are looking for in this question. It is equal to either 153 over 25 square units, so in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.